Hi, in this video we're going to have a quick look at an approach I used to optimize my game Blok Boy to get some performance out of it to make a more arcade quality game. So I've called this Giving Blok Boy His Byte and How Bits Let Him Nibble, because we're going to be looking at an approach using binary. So stick around and let's have a look. So let's start with a little history. Blok Boy started out in 2007 as a Flash game. It was a learning exercise for me to get familiar with ActionScript, and interestingly enough, while I have the source code still for it, it won't work in the latest version of Flash, or what is now known as Adobe Animate. What a surprise. Now in 2014 I was playing around with Pygame, and I figured in Python I'd give it another bash. So you can see the screenshot here. I did it and it worked quite nicely as well. It looks very much the same as what the Flash version looked like, just because I don't have a screenshot of it here. Then in 2020, I needed a Pacman clone for my collection of games, and I thought, well, I've already written one twice, so let's just translate that across to BASIC. So I did, and there were a lot of issues. Well, there wasn't a lot of issues with the game, there's a lot of issues with performance, because of course BASIC not quite the same when it comes to running on a machine that's got, maybe a tenth or a hundredth of the speed of a fast PC running Flash or Python. Now in 2022, after a bit of optimization, everything else, and basically taking my time, mucking around, I came up with Blok Boy, which is basically the final version, all optimized, and with a whole new kind of theme to it. Obviously blocks, hence the name Blok Boy. Now the original way that the ghosts would travel the maze, which turned out to be the biggest bottleneck, was by moving across into each square of the maze, and as they got to each square they'd check for, is there any exits? They'd scan the exits and then they'd check, can I change direction? Obviously you don't want them to move into a wall, and also when they're moving you don't want them to go back on their own paths. So the general rule is if they're moving vertically, then when they reach somewhere with a horizontal exit they can make a decision whether to move or not. Now we're going to have a quick look at this and I'll show you what it looks like and what the problems were when it got translated into BASIC. We can see in this original version that I did by porting the code across, where it checks the exits every time it hits a dot. It creates this horrible kind of pulsing motion because the amount of calculation time it takes as it kind of reaches each dot for all four ghosts to check is enough to put a small delay in there. It's not very appealing, it's not very smooth, and it's something I had to look at fixing. I needed a way to optimize that, obviously, and I thought, well, the maze doesn't change. The maze is the same, doesn't dynamically get built. Is there a reason we really need to even ask the code to check exits when we could just pre-record the exits information into the maze itself? So that's what I did. I made a maze data structure that didn't just have the dots and the walls and everything else. Instead, I made the maze structure with the paths in it, saying is there exits in up, down, left or right direction, so that when the game was running, the ghosts and the Pacman and everything else just had to analyze the square it was moving into on the maze and go, which way are the available exits? Now we're going to have a quick look at the difference this made once I added this approach into the game itself. Now once we have these pre-calculated exits stored in the data, see there's no processing time required apart from a quick check of some binary data, and it makes everything move so much smoothly and a lot faster. So it is a much better approach to use. Now the way this worked was originally the data structure for the maze was really just a tile map. It had walls, it had dots, it had power pills. And of course when you're moving around in this maze and using the old method, you're checking the tile map to say is there a dot above it or is there a wall above it or links to it. That's quite time consuming, and why do we even need to be checking that when we actually know where the exits are? So what I did was I looked at the maze and I converted it into a bunch of data that represented where the directions were. So what we have here is all the corners and kind of junction points. Obviously the ones in the middle, the dots, will only have either an up and down or a left and right, but where things end and corners and intersections, they have their exits noted in there with these little arrows. I needed a way of storing this in my maze data, and I thought I'd go for a more compact data format using binary. So what I did was, for each of those blocks in the maze, I set up 8 bits. So the top 2 bits, bits 7 and 6, represent left and right. Bits 5 and 4 are up and down. And then the bottom 4 bits store the dot information, because obviously you're going to need a way of recording whether there's a dot or a power pill in that square, or whether it's been eaten or not. So you need to be able to turn it off and turn it on. So bit 0 goes on and off, based on whether there's a dot available. And if it's a power pill, then bit 3 will be 1. So we don't change that. We just query that when we eat a dot if it exists. Okay, so typical example here, we've got a dot. Okay, it has a left and a right exit, so the top 2 bits are 1s. Can't move up and down because of course there's a wall above and below, so it has 0s for up and down. It's not a power pill, but it does have a dot, and the dot hasn't been eaten yet, so bit 0 is set to 1. Now what about power pills? The one in the corner, say it's a power pill. Now it can only go left and it can only go down, so those bits, bit 7, bit 4 are both set. The bottom 4 bits, well, it's a power pill, so bit 3 is set and bit 0 is set. Because the process is all about binary, I thought probably for those people who are new to programming, who are going, I don't understand bits, bytes, nibbles, whatever, what the heck is Kev talking about? I'd do a quick speedy little binary 101. Now binary in terms of numbers from 0 to 255, or what we call 8-bit, are represented by 1s and 0s. Okay, now we have 8 bits. It starts from like bit 7 on the far left and ends at bit 0 on the far right. And you'll see above each of these bits, 7, 6, 5, 4, 3, 2, 1, 0, each one has a value. 1, 2, 4, 8, 16, 32, 64, 128. Each one is just double the previous one. And to represent or convert between binary and a decimal number, you're basically just adding up the values related to the bits that are set to 1. And you can see down on the bottom there, the first bit, or bit 7 I should say, 128, plus 16 on bit 4, plus 4 on bit 2, and plus 1 on bit 0. The way that we're going to check if there's a bit of information on or off in the maze is to use a mask. In this case, the AND bitwise operation, which is a way of placing like a mask, I guess, with 1s where you want to keep the value and 0s you want to blank them out. And then what it does is it just keeps the values that have 1 in both of those, the mask and the value we're masking. So you can see here in my example on the right, the top one is the mask. We want to keep bit 7, 6 and 5 we want to blank out, and bit 0 we want to blank out. But we're going to keep all the numbers or whatever the values are for those bits that have got 1. And when we AND it or mask it down on top of this actual value we have here with 11011, sorry, try and say that a million times really quickly, we can see the result is basically that number, but with those masked out ones zeroed. So we can use it, for instance, if we use a mask of, say, bit 0, so the number is 0000001, it'll just basically mask out that bottom bit. And if it's a 1, it'll return 1. If it's a 0, it'll return 0. So we can use it just to check where the values are. And that leads us into this code. So just to see how that's being used, if we set the maze block data, that little byte of information, into the variable %n, if we want to find if there's a dot, we just have to check bit 0, which we know is a value of 1. So we just go if variable n and 1, we'll just mask out that bottom bit. Now, if bit 0 is 0, well, it's going to be false. Bit 0 is 1, then 1, and it's masked, will return 1. Now, the reason you do that is because you have all that other information inside the data there, the up, down, left, right, power pill. We want to just blank those out so they don't get in the way of us checking just bit 0. So that's why we mask it with the AND. Now, if we want to remove the dot, that's bit 0, which is 1. Now, the maximum number that we have inside an 8-bit digit or 8-bit value is 255. And because bit 0 is the 1, we just subtract 1. So that's 254, which means all the bits will be kept except for the very last one, which will be a 0. It'll blank it out if it's there. Of course, we can do the same here. If it was a power pill, then bit 3, which is a value of 8, is checked. If we want to find out where left, right, up or down are valid, then down the very bottom there, you see we just AND it with 128, which is bit 7, 64, which is bit 6, and so forth. Now, the nice thing about grouping those bits together for left, right, and up and down is if we just want to do a quick check, say, are there any horizontal exits? Can we change direction here? Then we just have to mask it by basically those top 2 bits. And in this case, n and 192. 192 is just basically 128 plus 64, which is bits 7 and 6. If anything comes back out of those, then there's obviously an exit in there. And same with the vertical exits. So that's how it all works. after all that, if you're thinking, oh, I've got to check this game out, then you can go and check it out on my kevman3d.itch.io account. It's free. There's documentation, but though I haven't fully documented the game, I have documented some of the technical stuff in there. And of course the game is there, and you can change the code, you can play around with the code, you can change the graphics, have fun with it, use it as a learning exercise. That's it for this time around. Hopefully this was interesting, or something a bit different than just talking about a command in BASIC. So don't forget, if you want to subscribe and click that bell, you'll get to find out when I get my next video up. Till next time, ta-ra!